Okay, today let us discuss something about vector quantity and the operations that are allowed in vectors. So, to know what is a vector quantity, we need to know what is a physical quantity. We need to know what is a physical quantity. A physical quantity is a property of an object in the universe that we can measure and give a value of it. So, to be a physical quantity, a property to be a physical quantity, it has to satisfy two quantities, two features. First one is it has to be measurable, and a value should be there after measuring it. Okay, then that kind of quantity or property is known as physical quantity. Physical quantities are of two types. At the foundation level, we have to discuss physical quantity. One is called scalar quantity, and another is called vector quantity. For scalar quantity, to get the value of it, we need only the number, only the value, and not direction, such as distance, length, mass, value of length, value of mass, and value of something like, say, time. Okay. To get the value of these quantities, we do not need any direction. Such quantities are known as scalar quantities. For vector quantities, we need a direction. Okay, in addition to the value of the quantity of the measurement. So we need additional direction, additional value, that is direction. Okay, and examples include force, your acceleration, momentum, torque, etc. Okay. So up to now we discussed only two types, and that is scalar quantity and vector quantity. In higher classes, we will include tensor also. Tensor is the general form of term that describes such quantities, scalar, vector, and other quantities that has more than one directions and different values in different directions, etc. So that topic, that is tensor, will be discussed in higher classes, and up to at the foundation level we will discuss only the scalar quantity and the vector quantity. And vector can be represented. If we have to represent vectors on paper, we will need an arrow overhead. Okay, this will represent the vector quantity, and to represent its value, that is magnitude, or its strength. Okay, we will denote it. We will take absolute value of it, or it only be represented by A. Okay, if I represent a vector, say 500 meter towards east, a vector towards east by this arrow. Okay, that this direction will be towards the east, and this length will be proportionate to this amount, this value 500 meter. Okay, so I am drawing this arrow just to represent this vector 500 meter towards east here for my convenience. If I need it, I can draw it here also, no problem. Okay, without changing the direction and without changing the length of the arrow. Okay, this is about the representation of a vector on a blank paper. And now we come to another point of vector. Vectors can be added and subtracted. And so there are rules for vector additions. Okay, the first one we will discuss about triangle or vector addition, and next we will come to parallelogram law of vector addition. So, what is triangle law of vector addition? Triangle law of vector addition. Vector addition. Vector addition. Vector addition. Okay. If according to this law, if I can form if two vectors form two adjacent sides of a triangle in order, that means the endpoint of the first vector from the endpoint of the first vector, the endpoint of the first vector coincides with the starting point of the second vector. Then the resultant vector will be the closing side of the triangle drawn in opposite order. That means from the starting point of the first vector to the end point of the second vector. Okay. According to triangle law of vector addition, if two triangles can form the two adjacent sides of a triangle in such a way that the end point of the first vector coincides with the starting point of the second vector, then the resultant vector will be represented by the closing side of the triangle drawn in opposite order. That means from the starting point of the first vector to the end point of the second vector. Okay. Now let this vector be represented by A vector and this be represented by B vector, and the resultant vector be represented by R vector, and the angle made between this direction and B vector be represented by theta, and the angle made by resultant vector with A vector will be represented by phi. So I draw the perpendicular on the horizontal line like this to find the resultant vector. So this length will be equal to this projection B cos theta, and this is opposite side of theta. This will be B sin theta. From trigonometry we can easily find out. And now what will be the value of the resultant vector? Now the square of the resultant vector, square of hypotenuse is equal to square of the base, that means A plus B cos theta whole square plus square of the opposite side, B sin theta whole square. Okay, therefore this is equal to A square plus B square cos square theta plus twice AB cos theta plus B square sin square theta. Now this is equal to A square plus twice AB cos theta plus B square cos square theta plus sin square theta. Okay, this whole term is equal to 1 from trigonometric identity. We know that. Therefore, the resultant vector, square of the resultant vector becomes A square plus twice AB plus B square. So the resultant vector is equal to root over A square plus twice AB plus B square. This is regarding triangle law of vector addition, magnitude of the resultant vector. So what will be the direction of the resultant vector? The direction of the resultant vector will be given by this ratio tan phi is equal to opposite side B sin theta divided by base, that means A plus B cos theta, implies phi is equal to tan inverse B sin theta divided by A plus B cos theta. Okay, that is tan phi is equal to opposite B sin theta divided by A plus B cos theta, or phi is equal to direction, the angle made by the resultant vector with A vector is phi is equal to tan inverse B sin theta divided by A plus B cos theta. This is the value of the strength of the resultant vector and the direction made by the resultant vector with the first vector A vector. Okay, from this we can easily find out the resultant magnitude and direction. Okay, this is about the triangle of vector addition. Now let's come to parallelogram law of vector addition. parallelogram law of vector addition. So here parallelogram law of vector addition. So according to parallelogram law of vector addition, if two parallelograms form the adjacent sides of a parallelogram, then the resultant vector of the two vectors will be given by the vector drawn from the common point of the vector, diagonal vector drawn from the common point of the two vectors. That is, I completed this parallelogram and I draw a diagonal vector from this common point, okay, and this is the resultant vector of this A vector and B vector. Okay, this side is parallel to this side and are of equal length. Therefore, they will have the same magnitude. Okay, we can conclude it from the property of a parallelogram. Like this, this will also be a vector. Okay, and its magnitude is A. And to solve this, to solve the value of the resultant vector by using the parallelogram law of vector addition, I will just complete a right angle triangle like this. Okay, since this is B, okay, and this angle, let this angle be theta, and angle made by resultant vector with A vector be phi. So this vector is B sine theta, and this is B cos theta. Okay, this length. Okay, now this is a right angle triangle. Hypotenuse square is equal to base square A plus B. Magnitude of A is A vector is A, B cos theta whole square plus B sine theta whole square is equal to A square plus B square cos square theta plus twice AB cos theta plus B square sin square theta is equal to A square plus B square. I take this B square common, remaining terms are cos square theta plus sin square theta. The identity is equal to, from trigonometry identity, we know that cos square theta plus sin square theta is 1. Therefore, A square plus B square plus twice AB cos theta. Therefore, magnitude of the resultant vector or the strength of the magnitude vector or the value of the value of the resultant vector is equal to root over A square plus B square plus twice AB cos theta. And now we are left with the direction of the resultant vector. We find the angle made by the resultant vector with a non-vector. So this is A vector. Then we can easily say that in this direction the resultant vector orients. Therefore, now we have phi, tan phi is equal to opposite B sine theta divided by base A plus B cos theta. Therefore, phi is equal to tan inverse B sine theta divided by A plus B cos theta. Okay, this angle gives the direction of the resultant vector. And now we have known that vectors can be added, vectors can be combined, and there is let's say like this also, vectors can be components. The components of the vector can be taken in different axes. Okay, let's come to that point. How? If I represent this A vector, say R vector in a plane, then in a plane Cartesian coordinate axis, then this component along x-axis will be, if I give this angle theta, if this angle be theta, then r cos theta, and this this component along y direction will be r sine theta. Okay. And this is for the vector lying on a plane. If the vector is lying on a three-dimensional space, then we have to take its components. So let's see. This is the vector A vector. Angle made by this A vector with this y-axis is phi, and angle made by this A vector, the projection of this A vector on the xz plane with x-axis is theta. Angle made by the projection of A vector on xz plane with x vector is x direction is theta. Okay. Now, if this is phi, then this projection on xz plane will be a sine. Is it that? Yeah, right. A sine phi. Now, this angle is theta. Therefore, this component will be a sine phi cos theta, and this component will be a sine phi sine theta, and this component will be a cos phi. Therefore, this A vector is equal to a sine phi cos theta x cap plus a sine phi sine theta y cap plus a sine phi sine theta z cap x cap. What's that? Y cap is not that. Y cap is only a cos phi. Y cap is only a cos phi. Along y cap, you have only a cos phi, and along z cap, it's like this. Okay. Okay. This is how we get the components of the vector A vector on three different axes in space. So, in the first case, we saw we have found the resultant vector using the by drawing by representing it on a plain paper. That is we call it the graphical method of solving the resultant vector. And there is another method for finding the resultant vector. We call it the analytical method of finding the resultant vector. Okay, we say for example, if A vector is equal to A1 x cap plus A2 y cap plus A3 z cap, and B vector is equal to B1 x cap plus B2 y cap plus B3 z cap. Then the resultant of the two vectors, A vector and B vector, will be represented by R vector is equal to A vector plus B vector is equal to A1 plus B1 x cap plus A2 plus B2 y cap plus A3 plus B3 z cap. This is how we represent the resultant vector. And now the magnitude of the resultant, the direction of the resultant vector will be given by R vector by R is equal to A1 plus B1 x cap plus A3 plus B2 y cap plus A3 plus B3 z cap divided by its magnitude, that is A1 plus B1 whole square plus A2 plus B2 whole square plus A3 plus B3 whole square. This is the direction, this is the direction of the resultant vector. And now, if I have to find in particular the orientation of the resultant vector with A vector, then I find the dot product of R vector by R with x cap. And now it gives cos of that is the angle made by the resultant vector with the x direction. And if I find the resultant the product of R vector with R and resultant vector with the y direction, it gives the orientation of the resultant vector with the y direction. And now like this, if I find the product of the unit vector of the resultant vector with the z vector, it gives the orientation of the resultant vector along z direction. Okay. Thus, we can find the direction of the resultant vector in analytical method also. Okay. Another idea that I want to tell is vector addition is commutative. Okay. The vector addition doesn't change with the same order of addition. That is b vector plus a vector. And vector addition is associative. That is a vector plus b vector plus c vector is equal to a vector plus b vector plus c vector. If we say the order of addition, it doesn't change the result of the addition. Okay, in associative property. In the case of associative